So I'll be discussing how to perform the interception and union operation without using the built-in method. So for interception operation, what is required is to return a set result that contains elements that are common to both sets, let's say set A and B. So in this case, what I will do is to use the hash-based approach to look up element that is common to both A and B, and then add such elements to my result set. So for a step-by-step approach, what this means is that I'll first of all create an empty set that will contain the results of the intersection. I will then iterate through set A and then use the hash lookup to search for elements that is in set B that are also in set A. Now, any such element that is common to both sets, I will then add them up in my result set. And finally, I will return this result set, which will contain elements that are common to set A and B. Now, for this intersection operation, the big O performance of the intersection operation, what we see is that the time complexity is usually 0 bracket n. And in this case, the n is the size of the smaller set. Now, because I would have iterated through one set and performed a constant hash lookup on the other set, so the space complexity will be 0 bracket k. And in this instance, the k is the number of common sets. So if we are to look at some test case scenario, what we can look at, let's say, test case set A, scenario 1. Let's look at first scenario. In this first scenario, let's say set A has element 1, 2, 3, while set B has element 2, 3, 4. So in this scenario, we'll find out that the intersection of those sets will be 2, 3, which is the element that is common to both set A and set B. Then we can also look at another scenario where maybe we're going to be having an empty set as the result. So in this case, like let's say in set A has element 1, 2, and then we have set B, which has element 3, 4. So you find out that there are no common elements between these two sets. And so in this case, the intersection set, the intersection result set is going to be an empty set. And then finally, we can also look at another test case, which is a case where we may end up having a subset. So let's say set 1 have element 1, 2, 3, and set 2 have element 1, 2, 3, 4. So you'll find out that when the intersection operation is carried out, so we are going to be having a result set that contains element 1, 2, 3, which is also a subset of the first element. So then for the union operation, what is needed is to return elements that are unique to both set 1 and set 2. So in this case, what I will do is to iterate through set 1 and add all elements of set 1 to my result set, and also then look up element in set 2 and add all elements in set 2 also to my result set. So for a step-by-step approach, what this means is that I'll first of all create an empty set that will contain the result of the union operation, and thereafter I will iterate through set 1 and add all elements in set 1 to the result set. After which I will also iterate through set 2 and add all elements in set 2 also to the result set. Now take note that because I'm using the hash set structure, you find out that the duplicate element that is going to be in this result set will be automatically handled. And finally, I will be able to return a result set that will contain elements that are unique to set 1 and set 2. So let's look at what would now therefore be the big O operation. So in this union set, we find out that the time complexity is going to be O bracket N plus M. And in this case, N and M are the sizes of set A and set B, or set 1 and set 2. And also the space complexity is going to be O bracket N plus M. And then in the worst case scenario will be where there is no overlap. So let's look at some case scenario for this kind of union operation. Now we can look at a scenario 1 where we have set 1, let's say set A, that contains element 1 and 2, and then we also have set B that contains elements 2, 3, and 4. So when the union operation is performed, we are going to be having a result set that contains element 1, 2, 3. Then we can look at case B, where we have set A that contains element 1, 2, and also we have set B that contains elements 3, 4. So in this set, when the union operation is performed, we are going to be also having a union result that contains element 1, 2, which is unique to set A, and also contain 3, 4, which is unique to set B. And then we can look at a third case, test case, where we have set 1 that have element 1, 2, 3. And then we also have set 2 that have element 1, 2, 3. So in this case, the result of the union operation is going to contain element 1, 2, 3. And you see that the hash setup structure will automatically remove the duplicate, and we still end up having 1, 2, 3, though 1, 2, 3 are common to both of them. So thank you so much for listening to my video and for watching my video. Do have a nice time.